Hello friends, welcome to my next video, starting with chemistry with our new concept told as the mole concept. At first, let me define you mole. What is mole? Mole is any amount of substance. Any amount. Mole means we just can't compare mole with any chemistry or atoms, but mole is any amount. Alright, now if we got to see the formula of mole, that means if you want to see what is 1 mole in a molecule, one mole in molecule is mass of substance divided by molar mass. Alright, this is called as 1 mole, or we should say not 1 but mole. Mole in a molecule is mass of substance upon molar mass. Now let me give you an example. We have, let me say 32 grams oxygen. Then calculate its mole. Then simply applying the formula mole equals, mole is denoted by N, so mole equals mass upon molar mass, which is equal to, we have 32 grams. And to find moles, we have to just remember the atomic masses of every element. Of oxygen, atomic mass is 16, so 32 upon 16 is equals to 2 moles. Here we have got the 2 moles of oxygen. So like this we have to apply the formula everywhere just to find the moles of the substances. And now let me tell you some other formulas. So let us calculate the mass of atom. Interesting, right? So let's do it. Mass of atom. Of course all would know Avogadro number. So mass of atom can be given by gram atomic mass, the whole divided by Avogadro number. It is gram atomic mass, the whole divided by 6.022 into 10 power 23 grams. Now again, suppose we have oxygen. Then mass of oxygen atom is 16 upon 6.022 into 10 power 23 grams. This is mass of 1 atom of oxygen. Did you get that? Yep, it is mass of 1 atom of oxygen. Like that, any atomic mass divided by the Avogadro number will give the mass, or we should say gram atomic mass upon Avogadro number would give the mass of an atom. Let's have a focus over another formula which tells us number of gram atoms. Alright, number of gram atoms, which is equals to weight in grams, but obviously which we have been given in a question, the whole divided by its gram atomic mass. Now let me tell you that a difference between gram atomic mass and gram molecular mass. As usual, my favorite, consider oxygen. Oxygen Alright, now you just see what I write. Oxygen never stays in O. It's always O2. So oxygen, O is very unstable for oxygen. O is nascent oxygen, so O is very unstable, so it always has its O2. It means oxygen is dimolecular in nature, always stays in O2. So atomic mass here is 16, but molecular mass is 32, because oxygen molecule is O2. O2 is 2 into 16, which is equal to 32. So this is the difference between the atomic mass and the molecular mass. So guys, let's talk about another topic of mole concept. Another quite important topic, I must say, rather. The name of the topic is percentage composition. Actually, it is often asked in organic chemistry too, but in physical chemistry it has its own importance. Part of mole concept, of course. Simple formula, nothing but high weightage, of course. Percentage composition. Suppose we have an element, we have compound, H2SO4, sulfuric acid, and we got to find the percentage weight of sulfur. Let us consider percentage weight of sulfur. So if you want to do that, first step, find molar mass. H2 has 2, S molar mass 32, O4 16 into 4, 64. Sorry. So H2SO4 has molar mass 98. Alright. And what do we have to calculate? Percentage weight of sulfur. Sulfur has 32. So percentage weight of sulfur is weight of sulfur upon molar mass of H2SO4 multiplied by 100. I hope you did the simple percentage in the 7th grade. So it's the simple thing, just weight of sulfur upon the weight of the compound where the sulfur is containing into 100 equals 32 upon 98 into 100. This is the percentage weight of the sulfur. So this is the percentage weight, very high weightage, but okay, it's very important for us. And now we have another concept which is just a small formula but has a very high weightage in JEE, that is ideal gas equation. I'm sorry, triple lines for it. 4 lines, it's enough. Ideal gas equation. Now since many laws, like I won't just name them, but by Boyle's law, Charles' law and Avogadro's law, we can conclude that now pressure is, of course, P stands for pressure. So this pressure is inversely proportional to volume. Also, pressure is directly proportional to number of moles, and also pressure is directly proportional to temperature. Means according to this thing, as the volume decreases, the pressure increases. According to this thing, as the pressure increases, number of mole increases. As number of mole increases, pressure increases. And same with this, as temperature increases, pressure increases. So combining these three equations, we get pressure is directly proportional to Nt by V, or in simpler ways, PV is directly proportional to Nt. Plotting those graphs and all those wacky stuff, I must say, PV is directly proportional to N is Nt is expressed in an equation where PV equals RNT, or in simple ways you would study in your schools like PV is equals to nRT. P is pressure, V is volume, T is temperature, N is moles, and our guessed R is gas constant. And R has the value of 0.082 atmosphere liter per mole Kelvin. And this was our ideal gas law, where PV is equals to nRT is an important formula. And P is pressure, V is volume, R is gas constant having value 0.082 atmosphere liter per mole Kelvin, N is number of moles, and T is temperature. So that's where we end with the first part of the mole concept. We have nothing in mole concept rather than just formulas with percentage composition, ideal gas equation, and whatnot. Of course, number of moles. So just you have to go through all these formula. You have to remember them, of course, as it is JE. You can do nothing there rather than if you don't remember any of the formulas, as they just create the base of your topic. Of course, you have to understand this type of theories, of course, but formulas are also very important. So that's it. Thank you very much. Of course, if I've done something wrong for understanding, then please, I would like to hear those comments. Thank you very much.